Good morning, Year 10. I hope you're all doing well. I can't believe we're in the last week of half term before another holiday. This time has been absolutely flying by. We've got just this one last topic that we need to cover this week on ratio. As I said in the description on the task for today, most of you have done work on ratio before, so none of this should be too new. But we are going to be looking at some algebraic ratios and some more difficult problem solving. So today's lesson is all about just making sure that our foundations are really, really secure, ready to build on them for that really tougher, higher level content. So first of all, I'm going to go through these couple of fluency questions. Looking at fluency 2A, hopefully you've already green penned the top row. Looking at fluency 2A then, so we're writing the following numbers as fractions. So 100 to the power of minus a half. Well, think back to your index laws. If it's to the power of a minus, that means you do the reciprocal, so you flip it. So that's like doing 1 over 100, but all of that is to the power of a half. You've got to then think, what does to the power of a half mean? To the power of a half means you need to square root it. So you're actually doing the square root of 1 over 100. Well, the square root of 1 is just 1. The square root of 100 is 10, so your answer 1/10. You can do the same process now for part B. The minus means you're going to flip it, do the reciprocal, so it's 1 over 25. The to the power of a half thing, I'm going to do it in one step now. I know that that means I need to do the square root. Square root of 1, 1. Square root of 25, 5. And finally, part C, I'm going to do the same thing. I'm going to say it's 1 over 9. I need to square root it. That would give me 1/3. Okay, fluency 2B, find the nth term. First thing to do anytime you've got a sequence is actually just work out what's the rule. So the rule here, it's plus 3 each time. Therefore, the nth term, it must be 3n. Go back a term to the term before, that's positive 1. So your rule is 3n plus 1. In order to work out, is 28 a term in the sequence? Well, you need to say, well, is 3n plus 1 equal to 28? Let's solve that. So take away 1 from both sides. 3n equals 27. Divide by 3, n equals 9. Therefore, yes, it is. It is a term in the sequence because that's a whole number. It's the 9th term in the sequence, in fact. You don't have to just keep going on with the sequence in order to get to that. You can prove it algebraically. Okay, finally, fluency 2C. I'm actually going to do this on the next slide just so I've got a bit more space. Nth term of a quadratic sequence. Now, if I think back to the assessment we did in November, nth term of quadratic sequences was one of our worst answered questions. And it's because you studied it in year 9. It's not a difficult topic. You follow the same formula. And I've put in this to help you, as just to kind of jog your memory. So when trying to find the nth term of a quadratic sequence, it will always be in that lovely quadratic form of an squared plus bn plus c. You just have to do things to find out what a, b, and c are. So first of all, you want to work out what's the term-to-term rule. So that's plus 2, then we've got plus 4, then plus 6, and then plus 8. Then you do the next layer. This should be constant. If it's a quadratic sequence, the next layer down will be constant. So we're told 2a is the second difference. That's that one, plus 2. So if 2a equals 2, well then a must be 1. Then I'm told that 3a plus b is the second term minus the first term. That's that number. Also in this case, 2. So if I know that a is 1, I can say 3 lots of 1 plus b equals 2. So 3 plus b equals 2. Take away 3 from both sides. B must be minus 1. It's coming together. Then finally, a plus b plus c is equal to the first term. That's that one, which is 10. Notice how each of these rules, it was first of all looking at that number, then looking at that number, then looking at that number. We're just going along that line. Okay, let's substitute in. So we know a is 1. We know that b is now minus 1. And we're trying to find out what c is. So 1 plus minus 1, well, that's 0, plus c, so c must be 10. Substitute it into your final equation then, an squared plus bn plus c. This quadratic sequence must then be 1n squared, so just n squared, plus bn, so just minus 1n, so minus n, plus 10. That's your quadratic sequence, and that's it for today's Connect Grid. Good luck with today's ratio questions. As always, Year 10, any problems, do give me a shout on Show My Homework. I'll speak to you soon.